So how about we take a look at a few of my robots? The first one I'm going to share with you today is going to be a Lilybot with a microbit and a motor bit. This is the one I use for my novices. So for my brand new people to robotics, such as my littles who may just be getting started with coding, building, etc. So we will program this motor bit and microbit using make code, which is similar to Scratch. It's block based or a puzzle like programming. And this robot we would build and then add a sonar sensor, for example, to do obstacle avoidance. Some teachers then told me that their kiddos had outgrown microbit and could I do something with Circuit Playground Express? Well, of course we can. So for more advanced elementary school kiddos, here is another Lilybot with a Circuit Playground Express and a Cricket for a Circuit Playground Express. So this one you can do a little bit more high level coding. With both of these make code robots, you can also program them not just in the block-based code, but also in Java and possibly Python. So here is one that was doing obstacle avoidance this weekend at the Indiana State Museum. So there would be Lilybot with a Circuit Playground Express Cricket. You can also get a Cricket with a microbit to expand it, and you can also add an AI engine to a microbit to expand it. So that's on our list for one of our future iterations for the microbit. The next level up, maybe when they get to high school or middle school, is to add an Arduino. So we've had a Lilybot and DaisyBot be used for high school competitions, where one was an Arduino Uno, and the next level up of the robot, we used an Arduino Mega. So that's another way that we're able to expand our robot by also growing with the Arduino family, depending upon the capabilities of what the kiddos want to do with the robot. This one has been used in a competition with an infrared remote and an infrared receiver in order to have the robot navigate through an obstacle course. And finally, here we have Lilybot with a Raspberry Pi Pico W. This one has a battery pack. Notice it has breadboard. So we do put breadboards when we need to do electronics wiring. The Pico W mount, upper chassis, lower chassis, the two wheels, the motors. Here are caster wheels in the lower chassis, and then the module for the power bank. And then our final robot, here we have our ESP32. This is our newest baby to the bunch, so we don't have the code fully written for this one in the Raspberry Pi 4B quite yet, but there's the ESP32 and the breadboard with the upper module, the upper chassis, the wheels, the motors, a different kind of power bank, the caster wheels, and the lower mount.